Hello everyone, my name is Puya Atai and I'm here today to present on a domain-driven distributed reference architecture for big data systems. Today is the age of data. Today we create data at an unprecedented rate. Taking a brief look at the recent advancements in AI and big data, and the photo that I've placed on this presentation, you will have a clear idea of this Cambrian explosion in the data and AI landscape. A brief look on this image shows you that there are countless technologies in different areas of data processing, and there has been roughly $274 billion dollar invested in big data technologies alone. So this really highlights the fact that big data is really a thriving industry, and there's a lot of attention to this area. With the recent launch of successful large language models such as Bard and ChatGPT, big data is becoming even more increasingly important. In fact, big data is the axiom upon which AI achieves its means. But with all the undeniable benefit and with all the investments, the success rate of big data projects is not that high, really. According to a report from Databricks in collaboration with MIT, only 13% of organizations excel at their at delivering their data strategy. Other reports from Vantage Partners and White House have provided the fact that only 20 to 24% of companies have successfully adopted big data. So even though big data has gained a lot of attention and AI is becoming more and more ingrained in today's industries, still a lot of companies fail to adopt this new technology. Sure, I can make a API request and create this surreal image and put it here, but can I scale a multifaceted big data architecture for a large company? I don't think so. That's complicated. So what's the problem? Why these companies fail? There are several reasons of why these companies fail. And I have published 3 papers within the last 3-4 years that explores this area and tries to kind of unearth why companies fail at delivering on their data strategy. The first one is a lack of sufficient talent. Frankly, there isn't enough talented data engineers out there. There isn't enough data architects. There aren't enough people who know how to scale a big data architecture, who can absorb the complexities of this field, and who know the landscape of this field and the technologies in it. The second one is organizational culture. Organizations go through several stages of maturity when it comes to data. They usually start from kind of an ad hoc data tool or a script for extracting and transforming data. Then along the axis of change, they go into like standard data and data governance, and then finally completely data driven. However, it's really challenging because it pretty much affects a lot of the internals of the company and the ways in which they achieve their ends, and the dynamics of the workflows and all this kind of stuff. The third one is rapid technology change. Based on the photo that I've just shown you guys and girls 2 slides before this, the industry is actually rapidly growing, and big data and AI is really comparable to the JavaScript world, where you wake up every day and there's like a new framework, there's like a new library. Now there is like a new AI tool. There's like a new AI SaaS company. They've used OpenAPI APIs to, I don't know, to create a report based on the abstract on your paper, which can then turn into an image, which can then be consumed by other AI to turn into video. So technology is rapidly changing, and it's really hard to catch up. You will feel constantly burnt out trying to catch up with new changes and with new libraries and technologies. The fourth one is inherent complexity. Very simply, big data architectures are really complicated. They can grow gradually, and they can very easily reach an inflection point. They can easily accumulate technical debt if there's no data architecture, if it's naively approached, and they can get complicated very easily. The last one, and pretty much the most important bit for this presentation, is the data architecture. So data architecture, first of all, has an element of all the other things that I mentioned, and it's the entire organization of the company's data strategy embodied in its component, and with standards and guidelines that will guide the evolution of the data architecture, and that will guide the evolution of the big data systems. So data architecture plays a crucial role because it's pretty much the blueprint of what we want to do. And it's not about now, but it's more about where we are going and how will the system evolve. So what are we trying to solve here? What am I trying to do? I am trying to solve the data architecture problem. And one might ask, what data architecture problems are you trying to solve? Before answering that question, first we have to explore the current big data architectures and see what are the limitations with those. Based on two comprehensive systematic literature reviews that I've published within the last 3 years, there are three major generations of big data architectures. The first generation is the data warehouses architecture. The second generation is the data lake architecture, and the third one is kind of a multi-model hybrid cloud kind of architectures. There are some architectures that really don't fit into any of these three generations of big data architectures, but when that happens, they're usually in the third generation of big data architectures. So the first generation is more about ETL jobs, dimensional modeling, fact tables, take things out, put them into some data warehousing technology, and then from there on, just write a query, take it out, create a dashboard or whatever else, visualize it, and so on and so forth. The second generation is less about transformation from the initial point, but it's more about storage, storing it into some sort of object storage, such as S3 and AWS, and then from there on, extract the data again, and still you can create data marts for different purposes, and you will eventually have some sort of data warehousing outside of your data lake, which is a smaller version, but that is usually inevitable. The third version is pretty much using whatever that is available out of a box. So I don't know, let's use Redshift and Snowflake and Athena and Glue and Kubernetes and Kafka. Let's have EKS, and let's run a Kafka instance in it that is streaming data to some outside service. Or let's use something like MinIO and have something like S3 and create data and store it and version it there. So there's no limitation on what you can do in the third generation. It's just a matter of what the architecture is. While these architectures have different qualities and different trade-offs and different quality attributes, they're all suffering from pretty much the same issues, same architectural issues. First of all, there is this great divide of data. There is this chasm between the OLTP world and the OLAP world, where you always rely on some sort of upstream OLTP application to provide you with the right data in the right format. So if the software engineer decides tomorrow that they want to change the semantics of certain properties in certain domains of the business, the ETL pipelines will break, and if they don't break, you may end up with something worse, which is a data scientist or machine learning engineer using that data for some business purposes. And the divide of OLTP and OLAPs and bringing them so far from each other is one major architectural challenge. The second major architectural challenge is that all these architectures, and for some reasons, pretty much everybody in the industry has the idea of centralizing all the data in one place and without any attention to data quality. In fact, data quality for the most is just ad hoc. I had several meetings with solution architects of very reputable data companies in the world, and every time that I challenge this centralized data storage, and by the way, a lot of technologies are developed underlying the same assumption that we want to centralize all the data, and data quality is always a challenge. So every time I had this conversation with these people, they always told me that I have to do some ad hoc things to figure out my data quality, and there's no way to address this in a architecturally solid way. So when you have a lot of data coming from transactional area of your system, of your company, and then you bring it to OLAP, there are usually data engineers which will take this data and process this data and prepare them for some business processes. But the problem is that data engineers do not belong to any business domain, so they do not really know what these data are for, what are the semantics, what are they doing. And for that reason, when data sources proliferate, when data consumers proliferate, you always have a risk of data quality decreasing. In fact, the more data consumers and the more data sources, the less the ability to harness the value of data. And the time to insight increases, the backlog for data engineers increases. Some data scientists want all the data. They're not selective, and the security guys come and are like, oh, you can't give them that data. So data quality is always a challenge, and data is seen as an asset. And when I see it's seen as an asset, it's like a byproduct of some OLTP system, but not as a product, not something that has a product owner associated to it. So there's no product thinking associated to data. Anyways, there's much more I can talk about, but those are the main problems we are trying to solve here. And the solution to that is by shifting our approach from architectural standpoint, and instead of centralizing and dividing the data from OLTP and OLAP world, we adopted the idea of domain-driven design, microservices, event-driven systems, reactive systems, and some of the Linux philosophies, and created this. This is pretty much the 8th generation of this architecture. The first generation was called Neo-Mycelia, and this was supposed to be called Meta-Mycelia. There is Cyber-Mycelium. There are lots of other generations, but this is a current generation. Really, time doesn't permit me to explore this architecture. This is a little bit too much to absorb for this presentation, but I encourage you guys and girls who are interested to go and to read the paper. This has been tested in an actual company, but however, that's a limitation, because that's not a limitation. One of the limitations is that I haven't done enough empirical study to sort of test this in different environments, and that's what I'm doing now. So I've been doing an experiment for the last 3 months to try to improve and to try to test this architecture in different areas. Thanks a lot for your attention, and I hope that you found this interesting.